Hi, everyone. My name is Pranav, and I'm joined here with Arjun, Brian, Christopher, and Matthew, and we're here to talk to you about our project, Sapphire. We started off this project by examining a key statistic that at $5,000 per pound, saffron is the world's most expensive spice, and we asked ourselves, is there an engineering opportunity here? For some background, saffron is an internationally coveted spice for the flavor it brings to many cuisines, its cosmetic uses, and its medical uses. Today, it's harvested in 3 steps. The most labor-intensive part of that process currently is separating the spice strands from the flower they grow in. Each flower contains just 3 strands of spice, as shown here. Now, those numbers quickly add up when you consider a whole acre of this spice. Each acre contains 680,000 flowers, which are currently sorted by hand. This produces about $20,000 of retail value of the spice, but remarkably amounts to 700 labor hours per acre, 75% of which is the act of separating the spice from the flower. And that brings us to our problem statement, that a lack of automation makes processing saffron prohibitively expensive domestically, and that's where we hope to come in.
Thanks, Pranav. And now I'm going to talk you through the design and engineering of the overall system. Here, you can see an example of what a user might interact with when working with our machine. They would input a bulk of flowers into the top. These would traditionally have just been picked from the field. At the bottom, they would remove the desired product, the saffron stigma. Occasionally, the user would also have to remove waste products, which in this case are the flower stems and the flower petals from the machine. Our machine has 5 main subsystems, the first of which is the input vat. A user dumps flowers onto the input vat, and then these disperse the flower onto the orientation mechanism below. The orientation mechanism has a series of triangular troughs that oscillate up and down in order to orient the flower with the stem facing downwards and the bulb facing upwards. The cutting mechanism has 2 main parts, the blades and the fans. The blades traverse beneath the orientation mechanism and cut the flower at the base, or the vertex, where it splits into 3 separate parts, the stems, the petals, and the stigma. The stems are caught by the cutting mechanisms themselves. The stigma and petals remain in the troughs, where the fans will blow over them, forcing them through the orientation bed into the separator mechanism below. The separator mechanism features a fan and a conveyor belt that utilizes the difference in aerodynamic and geometric properties to separate the stigma and the petals. Here you can see where the stigma and the petals would be collected in the overall machine.
Thank you for watching, and we look forward to answering any questions you might have about Sapphire.